Hello everyone and welcome to the part 2 of AWS Storage Services Selection or Decision Guide. So this lecture will contain these two topics: primary use cases, not suitable for and key differentiators, and second, key points for certification, common exam confusion points, and some service limitations to remember. So first set of parameters are primary use cases, not suitable for and key differentiators. So first we have Amazon S3 and primary use cases are data lakes, backup archive, static websites, cloud native apps, big data analytics, media hosting, and it's not suitable for low latency transactional databases, any kind of shared file system workloads like native POSIX. Then some key differentiators are extreme scale and durability, cost effective tiers, rich features, strong consistency, and API access. Next we have Amazon EBS. Primary use cases are EC2 boot volumes, transactional/NoSQL databases, and enterprise apps. And this is not suitable for shared file access for most types, object storage, offline data transfer. And key differentiators are persistent block storage for EC2, and you have range of performance/cost options, snapshots, and encryption. Next we have Amazon EFS. Primary use cases are Linux shared file storage, web serving, content management, home directories, container serverless storage. It's not suitable for Windows workloads like SMB protocol, block storage needs, and high performance HPC computing. We call high performance computing. Key differentiators are it's elastic NFS v4 protocol file system. It has multi-AZ access. It is serverless, and it has POSIX permissions. Next, we have Amazon FSx for Windows. Primary use cases are Windows apps like CRM, ERP, and .NET, home directories, SQL Server, and media workflows. This is not suitable for Linux native NFS workloads, object storage, and high performance computing. Key differentiators are fully managed Windows Server file system. It supports SMB protocol, AD integration, and native Windows features. Then we have Amazon FSx for Lustre. Use cases are high performance computing, ML training, big data analytics, video processing, EDA, financial modeling. And it's not suitable for general purpose file sharing, Windows SMB workloads, and object storage. Key differentiators are high performance parallel file system, S3 integration. It scales throughput IOPS massively. Next, Amazon FSx for NetApp ONTAP. Primary use cases are migrating NetApp workloads, databases, VMware, enterprise file sharing, and hybrid workflows. This is not suitable for simple NFS and SMB needs and Lustre level performance because it is less than Lustre level. Key differentiators are it's a managed ONTAP features. Multi-protocol, it supports NFS, SMB, and iSCSI. It offers tiering and have good efficiencies. Next, we have Amazon FSx for OpenZFS. Primary use cases are migrating ZFS/Linux servers, data analytics, dev test, web serving, and media processing. This is not suitable for Windows SMB workloads. And if you want Lustre level performance, and if you want simple object storage. Key differentiators are managed OpenZFS feature support, high IOPS and low latency high IOPS NFS, and it offers tiering. Amazon File Cache. So primary use cases are cloud busting, accelerating hybrid workflows, ML training, data access. This is not suitable for persistent primary storage, general file sharing. And key differentiators are high speed temporary cache for S3 and NFS. It offers unified namespace and sub-millisecond latency. Next, AWS backup. Primary use cases are centralized backup restore, compliance adherence, and ransomware protection. Not suitable for real-time replication, disaster recovery, and primary data storage. Key differentiators are policy-based automation, multi-service support, central monitoring and auditing, and vault lock. AWS Data Sync. Primary use cases are online data migration, archiving, recurring transfers for hybrid workflows. This is not suitable for offline transfers, streaming data, managed file transfer endpoint like SFTP, etc. Key differentiators are automated and accelerated online transfer, multi-protocol source support, integrity checks, scheduling, and filtering. Next, we have AWS Snow family. Primary use cases are large-scale offline data migration, both ingress and egress, edge compute and storage. Not suitable for online transfers, low latency access needs. Key differentiators are physical transfer for petabyte scale, and this offers ruggedized rough devices and onboard compute and storage. Next, AWS Storage Gateway. Primary use cases are hybrid cloud storage access, backup/archive to cold, disaster recovery, and data processing feed. This is not suitable for fully cloud native apps, direct object/file access within AWS. Key differentiators are it supports standard protocols like NFS, SMB, iSCSI, and VTL. It offers local caching and managed appliance. AWS Transfer Family. Primary use cases are managed business-to-business file exchange through protocols like SFTP, FTPS, FTP, and ES2. Migrating protocol-based workflows. This is not suitable for general object storage access, high-speed internal data movement. Key differentiators are serverless MFT, multi-protocol support, native S3 EFS integration, and managed infrastructure. And last set of parameters are key points for certification, some common exam confusion points, and any service limitations to remember. So first, S3. Key points are storage classes. So it has many storage classes and they vary based on use case, cost, durability, availability, and latency. It has lifecycle feature, versioning feature, replication, security, strong consistency, and there is a S3 select feature. Confusion will be between storage class selection and IAM versus bucket policies versus access control list and encryption types, and some question will ask you to choose between S3 versus EBS and EFS. Limitations: max object size is 5 TB. Not a native file system. Needs tools like mount point. Request cost can be significant. Next, we have Amazon EBS. So key points are it has volume types like GP3, IO2, ST1, SC1, and they vary based on performance and cost. Snapshots. So there is a feature incremental. We have sharing. We have archive. Then we have encryption features and their performance factor, and we have multi-attachment support also, multi-attach. Some common confusion points are, so volume type selection, so it can be GP3 versus GP2 or IO1 versus IO2. Snapshots versus backups, and EBS versus instance store. Instance store is directly attached to EC2 when you launch first time, but this can be detached and attached to other EC2 also. Then EBS versus S3. Limitations: this is a single availability zone resilience. It is a availability zone easy resilience. It does not span to a regional level. Okay, and it needs snapshots and replication. Performance depends on the EC2 instance type. Multi-attach only for IO1 and IO2, and this cannot be no boot. It cannot be a boot device. Next, Amazon EFS. So key points are performance/throughput modes, and we have GP/max IO and burst and provision performance. Then we have storage classes like standard, infrequent access, and archive. So there are 3 types. Then we have lifecycle management. We have access points, regional versus one zone, and NFS v4 protocol. Some confusion will be around performance/throughput modes and scaling. EFS, which is this service, versus FSX, especially for Linux. EFS versus S3. Access points versus IAM/POSIX permissions. And some limitations to remember is throughput scaling linked to storage in the busting mode, and potentially higher latency than EBS/FSX. Primarily for Linux. Windows needs NFS client. Next, we have Amazon FSx General. So this is, I will come to all of individually next. So first is to know the 4 types. We have Windows ONTAP, OpenZFS, and Lusher. So these 4, and they're primary choosing between. So exam may ask you between FSx types, FSx versus EFS for Linux workloads. And limitation: each type has specific operating system / protocol compatibilities and performance profiles. So first we'll go over FSx for Windows. So key points are it supports assembly protocol, AD integration, Windows features like shadow copies, deduplication, single / multi-AZ options. Confusion can be over FSx Windows versus EFS / S3 for Windows shares, and when to use over other FSx types. Limitations primarily for Windows workloads and AD dependency. Next, FSx for Lusher. Key points for the certification are: it's a high performance parallel file system. It has S3 integration through linking. We have 2 mode, scratch versus persistent deployments. Confusions can be FSx Lusher, which is this one, versus EFS / S3 for performance, and scratch versus persistent durability / cost trade-off. And some limitations: this is primarily for Linux high performance compute, scratch data loss on failure, and no auto backup when linked to S3. Next, FSx for ONTAP, NetApp ONTAP. So key points to remember is NetApp ONTAP features it supports like Snap Mirror, Flex Cache, and associated efficiencies. It has multi-protocol support, NFS, SMB, iSCSI, and it offers tiering. Confusion can be between FSx ONTAP versus other FSx and EFS service. Use cases for specific ONTAP features. Limitations: complexity of ONTAP features, higher cost profile than simpler file system options. Next, FSx for OpenZFS. Key points for the certification are ZFS features like snapshots and cloning, NFS access, high IOPS, low latency, and we have tiering options. Confusion points can be FSx OpenZFS with this service versus Elastic File System or other FSx flavors, and benefits of ZFS features. Limitations: primarily it's a Linux / NFS focus, and storage capacity is immutable after creation, so it cannot be changed. So you have to create a new file system if you want to change the storage capacity. Next, Amazon File Cache. Key points are high speed cache for S3 / NFS, and use cases are it provides bursting and hybrid support, and Lusher client access also it offers. This is Amazon File Cache. Confusion: File Cache versus FSx for Lusher. So this is cache and FSx is persistent file system. So this is the main difference. And data consistency model. Limitations: temporary storage, not persistent. NFS v3 required for on-premises linking. Next, AWS backup. So key points for the certification are centralized policy management, multi-service support, vault lock, cross-region, cross-account copy, and restore testing. Some confusion can be backup versus snapshots, backup versus disaster recovery, DRS, and vault lock implications. So it has immutable. This vault lock is immutable. And some service limitations to remember: it's not a real-time disaster recovery. Restore times vary by the service or the tier which we have chosen. Cost implications of how much data retention and cold storage. Next, AWS Data Sync. Key points are online transfer acceleration, multi-protocol source support. It offers scheduling and filtering and integrity checks. Confusion can be over data sync versus storage gateway. One, this is migration, and storage gateway is hybrid access. So this is the main difference between these two services. And second could be data sync versus Snowball. So data sync is online, but Snowball devices are offline. So you save the data and then you send it over. So it becomes offline, snowball, right? And data sync is always online. And next, last could be data sync versus transfer family. So this one have different set of protocols. Limitations, it requires agent deployment on premises or other cloud. So agent needs to be installed either on prem or if you are migrating from other cloud. This depends on the network, the latency and throughput. And this is not for offline or not for streaming data. Next, AWS no family. Key points are offline data transfer, and this offers petabyte scale. It has edge compute as well as edge storage, and the devices are physical ruggedized device. Confusion can be between snowball versus snowmobile. So one is a truck and one is like a suitcase or a briefcase. And snowball versus data sync, which is another one, one is offline. This is offline. Previous one was online. And storage optimized versus compute optimized devices. So this is between this service itself. There are two flavors: storage optimized and compute optimized. Limitations: physical device logistics required. Transfer time includes shipping also. Not for online or low latency needs. Next, we have AWS storage gateway. So key points are hybrid access patterns, protocol conversion. So it can do a protocol conversion between NFS protocol, SMB, iSCSI, and virtual VTL, virtual tape library. It offers local caching. Confusion can be between gateway types. So this itself has three types: file type, volume type, and tape type. Next, we can have cached versus stored volumes. And lastly, storage gateway versus data sync. So this has more protocol support, and the data sync is online. And this one has different set of but there will be minor nuanced between data sync versus storage gateway. And limitations will be this requires on-prem virtual machine or it requires on-prem hardware. Performance depends on local configuration / network, and this can have potential single point of failure unless you configure the high availability. And lastly, we have AWS transfer family. Key points for certification is it's a managed SFTP, FTPS, FTP, and ES2 endpoint. It offers native S3/EFS integration, and it is serverless. Confusion can be between transfer family versus data sync. So one has different set of protocols and use cases. And next, transfer family versus direct S3 access. So direct S3 access can be API gateway and Lambda. And some limitations, service limitations are, so focus on specific protocols. So if these protocols are required, which are this SFTP, FTPS, FTP, and ES2, and cost per endpoint hour per enabled protocol. So this has different cost for different set of protocol, and it is charged per hour basis. So you will get an endpoint and you will be charged per hour based on which protocol you are using. And that's all. Thanks for watching.